Alright, this is section 1, and so we are ready to talk about describing motion. And so, first of all, we're going to talk about what is motion in general. And so motion just basically occurs when an object changes its position relative to a reference point. And so a reference, the key here is reference point. So your idea is, we'll underline that here, reference point. So a reference point. So we have to pick a point that we are talking about in general. So you might talk about, you might see like a mailman delivering your mail. Has the mailman moved? Well, yes, if you see it move in relationship to a reference point, meaning that in reference to your mailbox, in reference to you. But again, that's in reference to whatever you're talking about. It's important to choose a general reference point, and that's what the next point is talking about. The motion of an object depends on the reference point that's chosen. So if I choose an object, if I choose something that's moving, an object that's moving, is it truly moving? Like right now, you're sitting down, but you're moving because the earth is moving. So it's just a matter of choosing the right reference point. You're not moving in reference to the chair you're sitting in, but you are moving in reference to the sun and the stars. So it's very important to make sure that when we talk about motion, that we declare what our reference point is. So in physics, it's very, very important to be specific about our reference points. So we use distance to describe when we actually do have motion, to describe how far an object has actually moved from the reference point. So distance is just defined as how far an object is moved. Here in this class, we're going to use the units of the metric system. We're very metric focused in this class. So we're going to use the meter, which is the SI unit. We're going to talk about a lot when we get to the chemistry component about what SI units are, but for now you'll just understand that we're going to say SI unit and kind of agree, okay, this is what that is. So we'll use the meter, and we'll use the meter stick to measure in here. We'll never use inches or feet. It's always going to be meters. Maybe we'll use kilometers if we need to use a bigger unit, or maybe centimeters, or even go even smaller with millimeters for those smaller distances, like for measuring really small distances on a table or something, a much smaller unit. Okay, so we have distance, and distance is just how far you are from, you traveled. We have something called displacement, and so displacement is the distance and the direction of the object's change in position. I like to think about it as the second bullet right here. How far you are from the starting point. So we'll kind of make a little drawing here on our paper so we can talk about truly what displacement is. So displacement is, let's say we have a starting point. So this is our starting line, maybe like a race. I think we could think about it this way. And you travel this way, we'll say maybe like 5 meters. Okay, and so that would be a distance, right? You travel 5 meters and you stop right here. So we'll say this is the end line. And then you decide to turn around. We'll get our little toolbar here and maybe pick a different color if it'll let me. Oh. These nice fun little things. Let's see, okay. So let's say we're at this end line and I decide to turn around and go the other way. Now, I went from my end point back to my starting point, which is that same 5 meters. Okay, so notice start to end, end to start. So my distance here is a total of 10 meters. But look, I started over here, I went down, I went back. So where am I in reference to this starting point? I'm exactly back where I started. So my displacement is 0 meters because I'm exactly back where I started, and that's what displacement is. How far you are from the starting point. If I would have stopped right here, I would be at a displacement of 5 meters. So it's how far you are from where you originally started. Let's look at some other examples. So you traveled 50 miles east and then 35 miles west. What is your distance? Alright, so this way, and then what you figure displacement to. Okay, so I'm traveling 50 miles east, 35 miles west. And I like pictures with this, and so keep in mind, here is your coordinates. And always remember, never eat soggy waffles with this. Okay, so you've got 50 miles east, so they went 50 miles in this direction. Because you went 50 miles east. So they started here, traveled 50 miles in this direction, and then they ended. And then what did they do? They went west, not quite all the way back. They only went 35 miles the opposite direction. So they want to know, though, what is their distance? And they want to know what the displacement is. So the distance, though, is, to me, the easiest thing they should be able to calculate, because all you have to do is figure out the total. They went 50 one way, 35 the other way, add them together. So that's a total of 85. And how I got that, just so you see, is 50 plus 35, and that equals 85. Okay, now displacement, it's how far I am, again, it's how far I am from this starting point. So look, I'm right here. So it's the difference between where I started and here. So what would I have to do? I would have to subtract those numbers. So I'd have to take 50, subtract 35. Okay, so you do that, 4. So this one would be a value of 15 miles. Now the other thing is that if it's a really easy problem like this, look, I am this direction from where I started. Well, what direction is that? That's east. So 15 miles east of where I started. Displacement should have a number and a direction if you're able to determine that. Sometimes you're traveling in a circle, or you're traveling in a weird direction, maybe like northeast or something like that, that it's hard to tell. But if possible, you should give a number and a directional value to your displacement. Alright, let's try another one here. Okay, so again, they're giving us, and I'll put our little coordinate values over here. Never eat soggy waffles. So you've got that. So we're going 25 meters north. Okay, so I'm going up this way. 25 meters. And then so I'm starting here. I'm ending here. And then I decide to go from my end value, and I go the full 25 back. Well, guess what? This is kind of like the very first thing that I talked through with you, that, hey, we went all the way. Well, distance, again, it's the total. So 25 plus 25, so that's a total of 50. And one thing that we haven't really talked about in here that I probably should emphasize on this is that every one of your numbers should have a number and a label, because this is a measurement, which measurements have numbers and labels, so make sure that you're doing that. Then displacement. Oops. So displacement 25, 25. Remember this, since you're going in complete opposite directions, you are allowed to subtract those technically. So 0. Okay. Alright, let's try one more before I switch up and try something a little bit more difficult. You run a circular track that is 400 meters 5 times. Okay, so I have a circular track. Okay, so there's my track. And let's say right here is my starting point. And I decide to run all the way around this track. I do that times 5. And that track is 400 meters. Okay. So what's your distance? Well, the distance is just a 400 meter track times 5, because you did 400 meters and you did it 5 times. So that is just 2,000 meters. Okay? Your displacement, though, think about it. Your displacement, you're going around a circular track, so every time I'm ending right back here where I started. So your displacement, you're just going around in circles, you're always ending back where you started, so your displacement is 0. So if you're running in a circular track, you're always going back to the start spot. So your displacement will be 0. Now, every example we did so far is a nice, easy example where you're going there, you're going back, so you can use subtraction or logic, obviously, to get. Now, they won't always be that way. Displacements are not always in the same direction. They might be in opposite directions, so they can't always just be added or subtracted, so we need to do another step. So an example of this would be if we have something like this. So you have, and again we'll do our north, east, southwest right here. Okay, so you walk 4 meters east. So I'm going to walk 4 meters this way. So there's my start. And then I'm here because this is where I end, and I decide that from this end direction, I should have left a little bit more room, I'm going to go up this way 3 meters north. So I have this shape here, and I want to know what the distance and the displacement is. The distance, again, no matter what kind of problem it is, the distance should be easy. So the distance answers you should get right every time. Add. 4 plus 3 is 7 meters in this case. Now, the displacement is not as easy. Now, I know some of you have not had the algebra yet. And so this is kind of the bad thing about having the physics part the first semester, is that last year, you guys, a lot of you knew this formula already. Well, the displacement, right, is the distance you are from the starting point. Well, I'm ending here, starting point here, so I want to know this distance. Well, look at this. This is a triangle, and in fact, it's a right triangle. And let me redraw this with maybe not as much stuff over here. And again, I'm not a very good drawer. You guys will learn this throughout the year. Where this is right here 4, and this is 3. So I have a right triangle with 2 sides. I do not know this thing right here, this side opposite the right angle, which is called the hypotenuse. And so you have to use something called the Pythagorean theorem to figure this out. So here's the Pythagorean theorem. And where this is actually A and this is actually B, and you are solving for C. So all you have to do is plug in your 2 sides here. and square them. Okay, so in this case, I'm going to take 4 and I'm going to square it. I'm going to take 3 and I'm going to square it. And that will give me c squared. So in this case, it's going to be 16 plus 9 to give me c squared. So that's going to be 25 equals c squared. Now I have c squared, but I want just c because I want to find out what c is by itself. So to get rid of a square, what you have to do is square root both sides. So c is going to be equal to 5. So that side is 5, so that's the distance we're looking for, so we should have labeled that meters. And this is what I'm talking about, where you're going to get a weird direction. So they're actually going to be what? Northeast. So if you wanted to label this northeast, you could. I'm more happy that you at least found out that it was 5 meters by using the Pythagorean theorem. Okay? Let's try another one like that, because I know that was a little tough. Okay, so again, we have north, east, southwest, so you can have your directions to have a reference point. This one you're going to go 5 feet that way, south. Okay, and then once you go south, you're going to go, oops, I went the wrong direction. Can I undo that? There we go. Then you're going to go west. I've been so used to going east. Then you're going to go 10 feet that way. So this was our starting point, this was our ending point. So now we want to find this leg here for our displacement. And so we could redraw here if that helps you. Where we have 10, we have a right angle here. This is going to be 5. So again, distance, really easy. Last time I checked, 5 plus 10 is 15. And that's feet. Okay. Displacement, though, a little bit harder, right? Oops. Displacement. Helps if I spell it right. So your displacement is, you have to use a squared plus b squared equals c squared. And so where you could, and it doesn't matter, you could make this one A, you could make this one B, you could make either one A, B, it doesn't matter as long as the side opposite the right angle, so this one here has to be C. So I'm going to make, let's see, 5 squared, 10 squared equals C squared, so 25 plus 100 equals C squared. 125 equals c squared. Okay, and then you have to square root both sides. Okay, and then you take the square root of 125. So the square root of 125 is not a perfect square root. So with those kinds of numbers, you could go ahead and work it out with a calculator, or if you want, you can you could even leave it as the square root of 125. That's fine as well. That doesn't bother me, especially since I know we're early in our algebra career, so you don't know a lot of that. It's up to you. So, but that's what we're doing with those. So just kind of sum up what we talked about in this lesson, just kind of definition-wise, just to make sure that we're all on the same page. Distance, total traveled, and then displacement is how far you are from the starting point. So if you can remember those two things, I think it will help you with your calculations. Even if you're not real strong with the math aspect, if you can remember the definitions, I think it will help you. So now you're ready to start off practicing on your own, coming in, and we'll work through some of this in class.